Hello everyone. Today we will be discussing a question from IRODOV from mechanics. Question 1. Motorboat going downstream overcame a raft at a point A. Though is equal to 16 minutes later, it turned back and after some time passed the raft at a distance L is equal to 6 km from point A. Find the flow velocity assuming the duty of the engine to be constant. So let's try to picture this situation given here. So we have a river. Let's assume the river is flowing towards the right, this direction. And let's consider the velocity of the river to be u. So u is the flow velocity of the river. Flow velocity. Right. There is a motorboat going downstream. Downstream means in the direction of flow of river. Right. So there is a motorboat which is going in this direction, in the direction of the flow of the river. So it's moving in this direction, and at some point A, it crosses a raft. By raft, you can imagine any object which is not having its own velocity and it's moving along with the flow of the river. So basically, this raft is moving with the speed of the river itself or the speed of the flow itself, which is u. So at some point A, this motorboat, which is having its own velocity, its own engine, it's flowing downstream in the direction of the river, is crossing this raft. So after crossing the raft, the motorboat continues to move forward. So it's moving in this direction. Then they are saying in the question that after a time t is equal to 60 minutes. So after a time t is equal to 60 minutes, let's say at this point, and let's take this point to be point B. So at this point B, it turns back and returns back where it came from. So it is mentioned that once it returns, it continues to move forward this direction towards the left. After some time, passes the raft again. So remember, the raft was also moving forward along with the flow of the river. So the raft was moving forward in this direction. And let's say the raft is at this point here. And this is also the point where the river, the boat returns and reaches here and crosses the raft again. So let's call this point as point C. Right? Let's call this point C. So we know that the boat is moving with the flow of the river. So let's say the boat's velocity is v with respect to river. Boat's velocity with respect to river. So in that case, for a person, say observing from the banks of the river or the ground outside the river, he observes that the boat's velocity is not v. V is the boat's velocity with respect to the river. So he will see that the boat's velocity will be a combined velocity of the boat and the river, right? Because the river is also flowing, the water is also flowing, and the boat along with it, with its own velocity. So the net velocity of the boat as observed by this person will be v plus u. V being the velocity of the boat with respect to river, u being the flow velocity. Now the boat, once it reaches point B, it turns back. And remember, if you take the point A to B, by the time the boat reaches the point A, the time we can take it to be t is equal to 0. And point B, the time is given as tau. T is equal to tau. And this tau is given as 60 minutes, which is same as 1 hour, right? So the boat turns back. And what will be the boat's speed once it turns back? Now, it's clearly mentioned in the question that assume the duty of the engine to be constant. That means the boat is still moving with the same speed with respect to the river, even if it turns back. So the duty is assumed to be constant. The engine's work is assumed to be constant. So if that is the case, if when it's returning, it won't be coming with the same velocity v plus u, right? Although v will be same, but the effective velocity of the boat as observed from the ground will be v minus u, right? So question is we have to find the flow velocity. How do we find the flow velocity? We can relate the times first. We know the time taken from A to B is tau, and the time taken from B to C, we don't know that. So let's take the time to be T. T is the time taken from B to C. Right. So if you relate it now, relate the distances, and it's also given that there is a small information we missed. It's also given that distance from A to C, the raft, when it is at point C, is at a distance L from point A. So this distance is given as L, which is 6 kilometer, right? And remember one more thing. By the time the raft reaches A to C, by the time the raft reaches A to C, that is from here till here, the boat manages to go from A to B and return back to C, which means the total time taken by the boat from A to C, which is tau plus T, is the same time taken by the raft in reaching from A to C. I hope that's clear. Now, let's relate the distances here, which is the easiest way. So we can say that AB distance can be written as AC plus CB clearly. And AB, if you write it in terms of velocities, V plus U is the velocity of the boat with respect to river, and the time taken is tau. This is equal to AC. AC is the distance traveled by the raft from A to C, which is L, but we can also write it in terms of speed, U into tau plus T. I have taken the velocity of the raft to be U because it's moving, it doesn't have its own velocity, it's moving along with the flow. And tau plus T is the total time taken by the raft in reaching from A to C. Plus CB. CB, we know, if you consider the speed of the boat from B to C, that is V minus U, the time taken by the boat from B to C is T. Now we can simplify this. So V into tau plus U into tau is equal to U into tau plus U into T plus V into T minus U into T. So we can cancel out few terms here, I think. So UT can be cancelled out. U tau can be cancelled out. So V tau is equal to VT, or cancelling V. Finally, we are getting tau is equal to T, which is very significant here. Why? Because tau is the time taken by the boat from A to B, and T is the time taken by the boat from B to C. You may think, although the times are different, although the times are same, sorry, although the times are same, why is the boat traveling different distances, right? From A to B, it's covering more distance. B to C, it's covering less distance. The reason is, in the first case, it's traveling along with the flow. So its speed is more, V plus U. So it's able to travel more distance. But in the second case, when it's traveling against the flow, its effective speed is decreasing, which is V minus U. So in the same time, it's able to travel lesser distance. Anyway, coming back to the question asks us to find the flow velocity. To find the flow velocity, again, we can use a term containing the flow velocity u. So we can take the distance from A to C. You know that distance from A to C is L, which is also equal to u into 2 plus t. Or I can write it as L is equal to u into 2 plus t can be written as 2 times of 2, plus 2 and t are same, like we proved here. Or we can say u is equal to L by, or L is 6 kilometer, 2 into 2 is 1 hour. So this is 3 kilometer per hour is the final answer to your question, right? I hope it's clear.